And now, once I have this statement, A2 tells me there exists some x such that this is true. And now, since epsilon is less than s, that's true, and that's my contradiction. I guess that got erased.
Over here, you show that if epsilon is less than s squared minus a over 2s,
then you can get this.
Epsilon squared equals 0.
No, is bigger than a.
Right, is bigger than a.
Right. And once I have that, then I can apply A2 and say, well, okay, this is s minus epsilon, so there is some x in a that's bigger than s minus epsilon.
And then which leads to the equation where you need epsilon to be less than s,
exactly.
Not the other one.
Exactly.
So therefore, it's a contradiction.
This is a contradiction again. What was the contradiction to? I think I said it but didn't write down here. What's the contradiction to? Contradicts that x is an element of a.
Yeah.
Because if it's in there, its square is supposed to be less than a, not bigger than a. Okay. One of your tasks, the first task before you even tackle the homework that's going to be assigned, is going to be to go through this entire thing. Oh, but right, we do have one last thing. So everybody okay with the calculation now and where the contradiction comes from? Okay? So then we also have a equal 1. So what do we choose for s in that case?
1.
1, okay. And what about if a is less than 1? Now, option 1 is to go through this whole thing and try to reverse stuff, okay? Okay? And that might be a useful thing to do, but it's also not being sufficiently lazy, okay? So if you want to be lazy, you think about all the work that you just did and see if you can use what we just did to work out this case. Can anybody suggest? We proved something about when a is bigger than 1. We now have a less than 1. How could I use what I just did for this case?
A squared is less than a or something. I'm just saying.
Well, how can I get something that's bigger than 1 out of that?
If a is greater than 0, then 1 over a is greater than 1.
Well, a is greater than 0. So, yes, 1 over a is bigger than 1. Now I can apply the case I just did. What does it tell me? So there exists some, probably shouldn't use s in this case, let's use t, such that what?
T squared equals 1 over a.
Yeah, t squared equals 1 over a. Right? 1 over a is bigger than 1, and I just proved that I can find a t like that. I'm not calling it s because s is reserved, already for the statement of the theorem. But by what I did here, it tells me that there exists such a thing, right? And now how do I get s? If t squared is 1 over a, what squared is a? Now I've got you all scared about these inequalities and stuff, right? But this is nothing but algebra, okay? So
It's 1 over t squared?
yeah. Right? S squared equals 1 over t squared equals 1 over a. Sorry. Equals 1 over a equals a. That's the lazy solution, right? And you should always be looking for the easy way out, as long as it's correct. And what about uniqueness? Well, let's suppose s prime is less than s. And remember, we also need that s prime is positive. The uniqueness only works when things are positive, all right? So let's suppose we have 0 less than s prime less than s. What does that tell us about s prime squared?
Less than
less than s squared, which is a. So this is not a square root. That's where the positive part comes in, right? That's where the positive part comes in. Again, same thing with the inequality. You're going to square across the inequality. You need to make sure that everything is positive. Okay? So if you get less than s, you don't have a square root anymore because the square is less than s squared. And the same thing if you're bigger, right? So s prime bigger than s implies s prime squared is bigger than s squared. Again, s is positive, right, and all this, so. So again, we've excluded the two possibilities, right? There are only, if there were another square root, it would either have to be less than s or bigger than s. If it's less than s, then its square is less than s squared, so it can't be a square root. If it's bigger than s, then its square is